Today we are going to discuss on introduction of solid state from chapter Solid State of Standard 12 CBSE board. Let's begin the chapter. Letting me introduce you to the solids. What solids are exactly about. Molecules and particles, when they are arranged at fixed distance from one another, and they are having minimum internuclear distance between them, and each molecules are held together by strong force of attraction between them. Due to that, they acquire a definite shape, mass, and volume because the particles or the molecules are tightly held in the solids, which make them rigid and incompressible. Due to this property of particles and molecules, which are arranged in a definite position from one another, and they are held together by strong force of attractions, and the way they are arranged, in the order in which they are arranged, they are classified into two types. So we can see solids are classified into two types. There are amorphous solid and crystalline solid. Okay, so there are two types of solid on the basis of nature of order present in the arrangement of their constituent particles. First one is amorphous solid. We can see amorphous solid and here the crystalline solid. Amorphous solid. What are amorphous solid? Amorphous solid it explained on the basis of arrangement of constituent particles. When the constituent particles are not arranged in a regular pattern, or when they are arranged in a regular pattern for a short distance and they again randomly arranged within the entire solid, then they are called as amorphous solid. But when the crystalline solids are regularly arranged throughout the long distance and they are repeating in the similar manner in the complete solid structure, then they are defining the crystalline solids. Other properties like shiny surface. Crystalline solids have shiny surface. They are lustrous in nature. Amorphous are non-lustrous in nature. Crystalline solids are sharp melting point, while the amorphous have low melting point. For example, you can see it is written below that amorphous solids have some examples like chalk powder, glass, we can say that. Crystalline solids are like the salt, the regular salt that we eat, NaCl, hydrated copper sulfate. These are some examples of crystalline solid. If you really want to go into the depth of understanding how the molecules or particles are arranged in the structure, we can see into the diagram. We can look into this diagram. We can see crystalline solids. In crystalline solids, the molecules or particles are regularly arranged in an ordered manner in every layer of solid. Therefore, it has a regular arrangement. And this arrangement is quite clear. But when we see amorphous, over here we can see the particles or molecules within the amorphous solids are not regularly arranged. They are irregular, they are randomized. So this is the basic difference between the structures of crystalline solid and amorphous solid. Now let us go into the classification of crystalline solid. What basically the solid states are classified with respect to crystalline structure, means crystalline solid. With respect to crystalline solid, how they are classified. So there must be some base on the basis of which these crystalline solids are divided. So we can see, depending upon the interaction of particles and the molecule, whatever particles or molecules which are present within that crystalline solid and the interaction, how they are interacting within that solid, they are divided into 4 categories. Means you can think like this. There is a crystalline solid in which molecules are present. Molecules can be any particle. It can be any particle. It can be atom also, which are arranged. And how these atoms, how these molecules are interacting with each other and forming the entire solid crystal. This point is very important. And on that basis, it is being classified into 4 categories. First is molecular solid. We can see second is ionic solid, third is metallic solid, and fourth is covalent solid. In metallic solids, we can see they are further divided into three parts: non-polar molecular solid, polar molecular solid, hydrogen bonded molecular solid. Now we will see individually, we will understand individually what these solids are and how they are structurally arranged. Molecular solid. The name itself explains. As I told you, this is a type of crystalline solid. So molecular crystalline solid, we can say molecular crystalline solid also by repeat. No, I'm not repeating crystalline word again and again. So I'm writing molecular solid. Such solids, such crystalline solids, which are having the collection of molecules and which are having n number of molecules, and they are held together by intermolecular forces. Such solids are called as molecular solids. Means there is an interaction of molecules within that molecular solid, which led to the formation of molecular solid. Okay. And obviously, these molecular solids are soft. Why? Because there is a force of attraction, and the force of attraction is very weak. Therefore, the melting point is comparatively low to moderate in molecular solids. Molecular solids are again divided into three, as I told you previously in the chart: non-polar molecular solids, polar molecular solids, and hydrogen bonded molecular solids. So what happened in non-polar molecular solid? How you're going to define it? See, such molecular solids where the non-polar covalent bond is present between the atom. So those molecular solid which have non-polar covalent bonds present between the atoms are called as non-polar molecular solid. Like for example, non-polar covalent molecule is what over here we can see: hydrogen, dihydrogen, dichlorine, diiodine, solid CO2. These all are non-polar. Okay, so the bonding between them is non-polar. Like CO2, it is also non-polar. So solid CO2 is what? Dry ice. It is also a non-polar molecular solid, because the forces which are holding them together is very weak, London forces. Okay, so therefore they are also soft, and they are non-conductor of electricity and has the lowest melting point than other molecular solids. Next come polar molecular solid. In polar molecular solid, the molecules are held together by polar covalent bonds. Okay, so definitely if polar covalent bond is there, there must be dipole-dipole interaction between the molecule. For example, HCl, solid ammonia. Okay, and since there is a dipole-dipole interaction, because of the polarity in the bond, it is called as polar molecular solid. Why HCl is written over here? Because we know that hydrogen is positive charge and chlorine is negative charge, partial positive and partial negative, due to the electronegativity difference between them. Due to this, a dipole is generated, and when this molecule interact with another HCl molecule, it will result into the dipole-dipole interaction, resulting into the polar molecular solids at some temperatures. So they are also soft and they are also non-conductor of electricity, but their melting points are comparatively higher than non-polar molecular solids. Next is hydrogen bonded molecular solid. What is hydrogen bonded molecular solid? The name itself can say these molecular solids have hydrogen bond present in them. That means such molecular solids which have polar covalent bonds present between the atoms and hydrogen bonds held the molecule together, then it is called as hydrogen bonded molecular solids, like water in the ice form. In the ice form, it has hydrogen bond. Okay, so we can see in the next slide the diagrams to understand the concept behind it. Okay, you can see first a hydrogen bonded molecular solid. See, we can see this is the structure of one water molecule. Oxygen is shown in red color. Rest small molecules, small atoms are hydrogen. What is happening over here? We can see that oxygen being electronegative, which is shown by red color, and hydrogen being positive. In one molecule of hydrogen of one water molecule get attracted to the oxygen of another water molecule, forming hydrogen bond. Okay, let me clearly show you by the pen. This is of oxygen, this is of hydrogen, this is of hydrogen, and this is of oxygen. See, it is held like this. Now another molecule is like this. Okay, now another molecule is like this. So these are the water molecules. So what is happening? Oxygen is more electronegative. So it is having partial negative charge. Hydrogen is having partial positive charge. Okay, so since these two are in opposite partial charges and electronegativity difference, this hydrogen is partially get attracted towards this oxygen, leading to the formation of hydrogen bond. Okay, it led to the formation of hydrogen bond. Therefore, such kind of bonding is explaining the what? They are explaining the hydrogen bonded molecular solids. Now, when we see non-polar covalent molecules, we can see this CO2 is, as a molecule, is completely interacting with another CO2 molecule by weaker internuclear distance, forming solids. Which kind of solid? Non-polar covalent molecular solids. Okay. Same way, there is some other example, like I have previously told you, hydrogen is having partial negative charge and a positive charge, and chlorine is having partial negative charge. So due to this partial charges on them, due to the electronegative difference between the chlorine and hydrogen, there is a dipole generating over there. So when this molecule interact with another HCl molecule, there will be causing a dipole-dipole interaction between them, resulting into the formation of polar covalent molecular solids. Okay. Now, next type is ionic solids. Ionic solids. What are ionic solids? See, whenever we say ions, it means cations and anions. Okay. So when the constituent particles of any solid is ion or are ions, okay, then they are called as ionic solid. Means there is cation and anion present in the entire solid, which is making them held together to form a solid structure. And these cation and anion are attracted to each other by a strong electrostatic force of attraction. As we can see over here, NaCl. What we are seeing in this, one molecule is of sodium, one is of chlorine. Okay, so they are forming bond, okay, by a strong electrostatic force of attraction in this entire solid, and no cation and anion are free in this. Okay, this led to the formation of strong electrostatic force of attraction between them because of the difference in cation and anion charge. We know that sodium is positive charge, chlorine is negative charge. When they come close, it led to the formation of an due to electrostatic force of attraction, it led to the formation of ionic bond. Since the ionic bond is forming over here, such kind of solid is called as ionic solid. Okay. And this is the solid state of NaCl. But when we melt it or we dissolve it in water, what happened? These ions start free to move. They are free to move again because they get dissolved in it. In the molten state, they get separated, and in the dissolved state, the ions got separated. Na plus moves in the other direction, and the chloride ion move in the other direction. They are got separated, dissoluted. They get dissociated over there. And due to that, the ions start moving in the medium, and since it start moving, it start conducting the electricity. So ionic solids in solid state, they do not conduct the electricity, but when they are in molten state or in the dissolved state, they do conduct electricity. Okay, and yes, obviously there is a high melting point and boiling point for ionic solids because they are held together by strong electrostatic force of attraction, resulting into ionic bond. So our next metallic solid is, the next crystalline solid is the metallic solid. See, the name itself suggests you, when the entire solid is made up of metal ion, positive metal ion, and sea of electron, valence electrons surround this metal ion lattice. Then it is called as metallic solid. We can see into the structure directly that the positive are the metal cations and they are completely forming the solid core part, and the valence electron of the metal itself are set free over the surface of the entire surface of the metal lattice, and due to this electron are free to move anywhere over the metal surfaces, metal ion layer surfaces. You can say that they are delocalized throughout the solid, and due to this, since metal is positive, electrons are negative, there is definitely electrostatic force of attraction, which is making the metal ions to held together in a metallic structure, forming metallic solids. And here we can take the example of iron, gold, etc., metal, silver. All these are pure metals or metallic solids, we can say that. And they are good conductor of heat and electricity, and they have high melting point and boiling point. Our last solids are covalent solids. They are also called as network solid. So covalent solids are such solids which have atoms as their constituent present in them. Means the constituent particle in these solids are atoms. Atoms all together forming the covalent solid. And they are held together forming a large network structure by covalent bonding. They are continuously undergoing covalent bonding, these atoms, and they are undergoing a network formation, network chain formation, like a network chain. Okay, not just a single chain, but a network in a 3D arrangement. Okay, and forming a giant molecule. Then they are called as covalent solid. Means atoms are responsible for covalent bonding and the network formation within the solid. Then it is called as covalent solids. And these giant molecules, examples are diamond and graphite. Quartz is also the example. And they are very hard because of the giant structure, and they possess very high melting point. Okay. So these solids are non-conductor of electricity, but graphite is the example, which is the conductor of electricity over here. You can see the structure of a diamond. What is happening in the structure of diamond? We can see that every carbon, since carbon has valency 4, so every carbon is tetrahedrally arranged. Okay, every carbon is tetrahedrally arranged within the structure, and they are forming a network-like structure. We can see that carbon is tetrahedrally arranged with 4 bonds. Then below this carbon is again another carbon, then is again held by 4 bonds. So you can see a network-like structure is forming over here continuously by a tetrahedral arrangement. Okay, this is a tetrahedral arrangement. So this led to the formation of this giant molecule, okay, which makes the diamond the hardest substance, and with the melting point 3550 degrees Celsius. But what happened in graphite? And it is a non-conductor, diamond is a non-conductor, but what happened in graphite? We see there is a hexagonal shape. Instead of tetrahedral, there is a hexagonal shape. That means each carbon atom is bonded to 3 atoms. This is one carbon, it is handed to this carbon, and this carbon. And the attachment led to the formation of, you can see this. This is one carbon. This is second carbon. See, this one carbon is attached to 3 carbons. This is what they are saying. And forming a hexagonal shape. So what we are finding that since carbon is having 4 valency, only 3 valency is responsible for bond formation and leading to the hexagonal structure in the graphite, forming the layers in graphite. But 1 electron from each carbon is set free, and which is layering over this complete structure of graphite, which is moving over this complete structure of graphite, which is making it as a good conductor of electricity. Okay, so what we have seen up till now, we have seen introduction to solid, we have seen water solids. We have seen types of solid on the basis of arrangement of particles. And then what we have seen the classification of crystalline solids. Okay. And they are divided as per 4 types: molecular solids, ionic solids, metallic solid, and covalent solids. Now, I'm going to ask you some questions. You have to answer it because we have finished the introduction on solid states. Which type of solid is ZnS? Zinc sulfide is which kind of solid? You have to think on it. Okay. Now, second question is, which one is an example of non-polar molecular solid? Dry ice, water in a form, ice form, iron crystal, or glass? Think on the answers. I'll tell you. See, which type of solid is ZnS? Zn. See, you can understand like this. Zinc is a cation, and sulfur is sulfide over here is an anion. So when cation anion is present, it will be ionic solid. Okay. And when we say which one is an example of non-polar molecular solid, so we know that molecular solids in which there is no polarity. We know that here I have written ice. Here I have written Fe crystal. Here I have written glass and dry ice. See, H2O is a hydrogenated, hydrogen bonded molecular solid. Okay, this is a metallic solid. We know that, metal bonds. And glass, it is an amorphous form of solid. Okay, so what is left to define? Dry ice, which is called as solid CO2. We know that CO2 is non-polar in nature. So our answer is dry ice. Okay. So we have finished this topic, and the next part of the video, the next part of this chapter will be continued in the next video. Till then, thank you everyone.